So welcome back. Today I'm going to explain principal component analysis, which is also known as PCA. So before going on to the subject, I wanted to discuss one example here. Imagine you are judging a student performance. You look at study hours, assignment marks, attendance, internal marks, and many things. But finally you combine all of them and say this student is good or this student is average. That means you reduce many features into one final score. This idea of reducing multiple features into fewer features while keeping important information is called dimensionality reduction. Today we will understand how and one important dimensionality reduction technique, that is nothing but principal component analysis or PCA. So dimensionality reduction means reducing the number of input features while keeping the most important information. For example, instead of separately using study hours and assignment marks, we combine them into one feature that captures maximum information. So what is PCA? So PCA is a technique that finds a new direction in the data that captures maximum variance. So variance means nothing but spread or information. So PCA creates new features called principal components. That is nothing but it reduces the number of dimensions. Okay, so PCA finds the best direction where the data varies the most and keeps the particular direction. If you see here, I have been taken one example here. Here we are having two features. One is x1 is nothing but the study hours that a student studied, and x2 is nothing but assignment marks. So our data is nothing but this is x1 and this is x2. Okay, number of hours studied and how many marks you have been scored. So we want to convert this 2D dimensional data into one dimension using PCA. First we calculate the mean. So if you see the data set, we will be calculating x1 bar, x2 bar is nothing but the mean of hours studied and the mean of the assignment marks. So if you see here, the mean of assignment study hours is 5 and the mean of assignment marks is 9. So we will calculate the mean because PCA works on centered data. So this is how the centered data looks like. So initially these are our data points. We need to minus the mean. So if you see here, the mean of x1 is 5. We need to minus this with every feature. Okay. Even in the same way for x2 also the mean will be 9, and you need to subtract this with the x2. Okay. That is these values are nothing but we call it as centered matrix. Okay. This process is called centering in the data. So PCA always works on centered data. So now we are calculating the variance. Okay, variance tells how much the data spreads. Here both study hours and assignment marks have similar variance, that is nothing but 6.67 if you see here. Okay, so y3, so n minus 1 is the formula. That is what you need to remember. Okay, so if you see variance of x2 also 6.67 and variance of x1 also 6.67. That means both features carry equal spread of information. So now we will be calculating covariance. Covariance is nothing but you need to multiply each and every term of the centered data with the matrix that we have been written in the above. So if you do it, so 6.67 x1 x2 means you need to take x1 values first into x2 values next. Okay, if x2 x1 if the data set similar, the data set that we have took is similar, that's why I am not calculating x2 x1 because the values will be similar. Okay, so already we know the formula. So if you look the formula, this is the formula variance of x1, covariance of x1 comma x2. This is how the matrix looks like. Covariance of x2 comma x1 and variance of x2. So all values are similar. We will be getting 6.67, 6.67. All these values are similar, right? So next, now we will be calculating the eigenvalues. So eigenvalues tells how much variance have new direction contains. Here one eigenvalue is 13.14 if you calculate 13.34. Another eigenvalue is 0. This means almost all information lies in one direction because one is 0, another one is 13.34. So 0 we will be ignoring and 13.34 will be calculating. Okay. So I think these eigenvalues, this is how you need to calculate the eigenvalues. Okay. So after finding the determinant, you will be getting lambda square will be having two values. One is 13.34 and the one is 0. So we can reduce from 2 dimensions to 1 dimension without losing any information, because one is already 0. We are ignoring that. And another one is 13.34. So we are going in one direction. Now let us calculate the eigenvector. So the eigenvector gives the direction of maximum variance. Here the direction is equally influenced by study hours and assignment marks. If you look here, okay, equally will be having. So this is nothing but we need to normalize it, and after normalizing it we need to divide it by every term in the vector, okay, that we got. Okay, so I am taking only the first row. If I calculate only the first row, I will be getting v2 is equal to v1. That is nothing but the coefficients are 1 1. Okay, so and after normalizing I will be getting root 2. Okay, then here comes the transformation of data. If you divide that vector that we have got is, for example, so v is equal to 1 comma 1, that we, after defining the vectors we have been got. So after normalizing it, if you normalize it, then we need to divide it by 1 by root 2, and this you need to divide by root 2. So if you do this, you will be getting 0.707, 0.707 as the values. Okay, now if you look the first row of the centered data, -3, -3, -1, -1, 1, 1, 3, 3, that is the thing we have been got, right? So you need to, now the main last step comes here is nothing but you need to multiply this -3 with this value, -3 with this value. Here the values are similar, so nothing to worry. You will be end up getting -4.24. And if you multiply -1 with this value and -1 with this value again, you will be end up getting -1.41. And the same way 1 1 and 3 3. If you do it, you will be getting this. Okay. So we successfully reduced from 2 dimensions to 1 dimension while keeping the maximum variance. Okay. So PCA reduces dimension by keeping maximum information and removing redundancy in